Hello dear students, this is your engineering mathematics 3 lecture. Today's topic is binomial distribution. Actually, we have started this topic in previous lecture. We have discussed the formula of binomial distribution and solved some examples, few examples of binomial distribution. Now here in this lecture also, we are going to discuss few examples on binomial distribution. So see the example. On an average, a box containing 10 articles is likely to have 2 defectives. If we consider a consignment of 100 boxes, how many of them are expected to have 3 or less defectives? What is the example? Here. On an average, a box containing 10 articles is likely to have 2 defectives. If we consider a consignment of 100 boxes, how many of them are expected to have 3 or less defectives? Here, a box containing 10 articles is likely to have 2 defectives. So, the probability of a box containing defective articles is 2 by 10 because a box contains 10 articles, means n is equal to 10. And so what is the standard probability of a box containing defective articles? It is 2 by 10 because in a box there may be 2 defective articles. So the probability of a box containing defective articles is equal to 2 by 10. 2 by 10 means, if you simplify it, it is 1 by 5. Q is the probability, P is the probability of success. Our success is a box, success is here, probability of success is 1 by 5. The success is in a box of 10 articles, there may be 2 defective articles. Now, probability of non-defective atoms means probability of failure is here 1 minus P. 1 minus P, 1 minus 1 by 5. 1 minus 1 by 5 is 4 by 5. So this is the probability of failure. Okay. Now, probability, we are interested. If we consider a consignment of 100 boxes, how many of them are expected to have 3 or less defectives? Means we have to find out in a consignment of 100 boxes, how many of them are expected to have 3 or less defectives. To find the number of defective articles, 3 or less defective articles in a box, in a consignment of 100 boxes. First, we are going to find a probability. Probability of a box containing 3 or less defective articles. Here, probability of a box containing 3 or less defective articles is equal to P of R less than or equal to 3. 3 or less defective. So the condition is there, the value of R is less than or equal to 3. Okay, it is equal to. Now, how to find the probability when there are 3 or less defective articles in a box? It is equal to, you start from 0, means when R is equal to 0, there may be 0 defective articles. Here the condition is 3 or less, means you start from 0. R is equal to 0, R is equal to 1, R is equal to 2, R is equal to 3. And then you add all the probabilities because these are the independent events, means exclusive events. So you add all the sums, probability of R is equal to 0, probability of R is equal to 1, R is equal to 2, R is equal to 3. 3 or less, so up to 3. Now P of R is equal to 0. Here we are going to use binomial distribution because the value of n is small, n is equal to 10. There are only 2 outcomes, defective or non-defective articles. Now when R is equal to 0, what is the probability by using binomial distribution? The formula is NCR P raised to R into Q raised to n minus R. NCR, n is here, n is equal to 10. So 10C0 because R is 0. NCR is equal to 10C0. P is 1 by 5 and R is 0. So 1 by 5 raised to 0. Q raised to n minus R. The value of Q is here 4 by 5. And the power is n minus R. N is 10 and R is 0. So 10 minus 0 is 10. So this is the probability of when R is equal to 0. The next term is P of R is equal to 1. Means when the success is 1, means there may be one defective article in a box. So what is the probability of that defective article in a box? It is using binomial distribution. Test 10 C1 because the formula is NCR. N is 10, R is 1. So 10 C1 P raised to R. P is 1 by 5 raised to R into Q raised to N minus R. Q is 4 by 5 because N minus R. N is here 10 and R is 1. So 10 minus 1 is 9. So it is 10 C1 into 1 by 5 raised to 1 into 4 by 5 raised to 9 plus probability of R is equal to 2. P of R is equal to 2. This NCR. N is 10. 10 C2 into P raised to 2 into Q raised to 8 because the value of R is 2 and the formula of binomial distribution is NCR P raised to R Q raised to N minus R. NCR N is 10 C R is 2 so 10 C2 P raised to R P is 1 by 5 raised to R R is 2 so 1 by 5 raised to 2 Q raised to N minus R Q is 4 by 5 raised to N minus R. N is 10, R is 2, so 10 minus 2, 8. So this is the term for probability of R is equal to 2. Then probability of R is equal to 3. It is 10 C3 NCR. N is 10, R is 3. NCR 10 C3 P raised to 3 P raised to R. P is here 1 by 5, R is here 3. So Q raised to N minus R. Q is here 4 by 5 raised to N minus R. N is 10, R is 3. So 10 minus 3, 7. So this is the term probability of R is equal to 3. Now adding all the terms, you calculate one by one every term and then do the addition of all the terms. Probability of every term is here calculated. This is the step where probability of every term is calculated and then you just do the addition of all the values. And so probability of R less than or equal to 3 is 0.8791. So this is the probability of a box containing 3 or less defective articles. Now next is in a consignment of 100 boxes, number of boxes having 3 or less defective articles is equal to. We want in a box of 100 boxes, in a consignment of 100 boxes, how many boxes having 3 or less defective articles? Now we have the probability of a box containing 3 or less defective articles. It is 0.8791. You multiply that probability by 100 and then the answer is 87.91. And 87.91 means approximately 88 boxes are there out of 100 having 3 or less defective articles. So this is the example of defective articles here. Now the next topic is mean and variance of binomial distribution. Mean and variance of binomial distribution. See, what is the formula of mean of binomial distribution? It is given by mean is equal to n into p. N is number of trials and p is probability of success. So the formula is n into p. Now variance of binomial distribution, it is given by variance, its notation is sigma square because for standard deviation we use the notation sigma and for variance it is sigma square. It is equal to n into p into q. You know what is n, what is p, what is q. N is number of trials, p is probability of success and q is probability of failure. Okay. So here now the example. The mean and variance of a binomial distribution are 6 and 2 respectively. Find probability R greater than or equal to 1. Here, R means the number of successes in n number of trials. You know, now mean is given, mean and variance. Mean is 6, and the formula for mean is n into p. Its value is 6. Variance is also given. Its value is 2. Variance is equal to sigma square is equal to n into p into q is equal to 2. Okay. Now you consider the ratio n into p into q upon n into p, n into p into q upon n into p, variance upon mean, because our aim is to find the probability of r greater than or equal to 1. Here r greater than or equal to 1, but we don't know the value of n. To calculate the value of n, you assume here the ratio variance upon mean, npq upon np is equal to, so npq means variance, its value is 2, and np means mean, its value is 6. So the ratio is 2 by 6. You simplify it, p get cancelled, n get cancelled, so the value of q is 1 by 3. Okay, this is the probability of failure. So from q you can find p, probability of success. Now in binomial distribution, p plus q is equal to 1. So we have the value of q 1 by 3. So you can easily find the value of p. It is 1 minus 2. And so it is equal to 1 minus 1 by 3. And so if you simplify it, it is 2 by 3. So the probability of success is 2 by 3. Probability of failure is 1 by 3. Okay. So now how to find the value of n? Now you know the formula of mean. Mean is n into p is equal to 6. Now we have the value of p, probability, it is 2 by 3. So put here the value of p, 2 by 3, n as it is equal to 6, because the mean value is given here, it is equal to 6. So p is also calculated here, 2 by 3, put here p is equal to 2 by 3, and so n is equal to, you shift this 2 by 3 in RHS and simplify it, then you will get the value of n, and here the value of n is 9. Okay, so the value of number of trials here, value of p, probability of success, probability of failure is also there, the value of q is probability of failure. Now we want probability of r greater than or equal to 1. Probability of r greater than or equal to 1 means you start from 1 up to which number? Up to number of trials. Now here number of trials are here 9. Means you start from 1 and you stop at 9. Means your answer is here, probability of r greater than or equal to 1 is equal to, probability of r is equal to 1 plus probability of r is equal to 2 plus probability of r is equal to 3, and so on up to probability of r is equal to 9. Like the previous case, here r is greater than or equal to 1 means you start from 1, and how many terms you have to calculate? Up to n. Here n is 9 means you start from 1 and calculate the terms up to r is equal to 9. Means you have to calculate the probability of 9 terms. So best way here, probability of r greater than or equal to 1 is nothing but 1 minus probability of failure. Now what is the failure of this probability of r greater than or equal to 1? Only r is equal to 0, this term is the failure. When r is equal to 0, that is our failure. So if we subtract the probability of r is equal to 0 from 1 minus probability of failure is equal to probability of success, because our success is probability of r is greater than or equal to 1. So to calculate this probability, you use the formula 1 minus probability of failure. And what is the probability of failure for r greater than or equal to 1? The failure is r is equal to 0. When the value of r is 0, that is the failure only, because we want the probability r greater than or equal to 1. Means to start from 1 to 9. So except 0. We find the probability of all the terms start from r is equal to 1 to 9. So the missing term is only r is equal to 0. So it means that it is the failure. And so to calculate the probability of success, means probability of r greater than or equal to 1, you just subtract that probability of failure, means probability of r is equal to 0 from 1. You will get your answer. So 1 minus what? How to find probability of r is equal to 0? Binomial distribution. N C r p raised to r q raised to n minus r. Now n is here 9. So your combination term is 9c0 because r is 0. NCR means 9c0. P raised to r. What is p here? P is here 2 by 3. 2 by 3 raised to r. What is r? R is here 0 because the success is 0. Q raised to n minus r. Q is here. The value of q is 1 by 3 raised to n minus r. N is 9 and r is 0. So 9 minus 0, 9. So you calculate the value of this term 9c0 into 2 by 3 raised to 0 means 1, 1 by 3 raised to 9. 9 C 0, its value is also 1. So the simplified term is there, 1 minus 1 by 3 raised to 9. And then you calculate the value of this probability of R greater than or equal to 1. It is 0.4 times 9. So this is your answer. This is the probability R greater than or equal to 1, 0.4 times 9. So these are the examples on binomial distribution we have discussed today. Any other topic binomial distribution is over. Thank you.